Alright, good people, this is section R-6, Rational Expressions. And as always, when you come across a question, I want you to write it here. And I'm going to be dropping some personal information just to make sure that you are listening. So when you hear it, just write it down there for an audio check. So without further ado, let's get started. So rational expressions, what does it mean to be rational? Well, rational in this case means resembling a ratio. And a ratio is another word for a fraction. So all these expressions are going to be, they are not polynomials, they are rational in that they resemble a fraction. So one thing I do want you to remember is that when it comes to fractions, they're very similar to division in that, when 8 divided by 0, you try and do 8 divided by 0, you get a undefined answer. It if you try to do it in a calculator, it comes up with an error. And undefined is different from we have an answer. It's like we don't have an answer. 8 divided by 4 is defined as 2. 8 divided by 8 is defined as 1. 8 divided by 1 is defined as 8. But 8 divided by 0 is undefined. It has no answer. That's very different from saying 0 divided by 8 is equal to an answer. The answer is 0. Here, you can't even say that the answer is 0. There is no answer. It's undefined. No answer. So we can say that x equals 0 is not in the domain of 8 divided by x. Domain is all of the available input. The way that we write this is we say that the domain is all numbers except for 0. Domain is all x such that x is not equal to 0. It's a very funny mathematician way of writing it, but there it is. So you can see here it says find the domain. Well, you look at the bottom and you say, well, this can't, x minus 5 cannot equal 0. So therefore x cannot equal 5. So the domain is all numbers except for 5. The way you write that is all x such that x is not equal to 5. Like, you can pick any x you want, just make sure it satisfies this condition, that x is not equal to 5. Let's do that again. Here, we have to make sure that this is not equal to 0. So therefore, let's factor it. What two numbers add up to 7 and multiply up to 12? That's 3 and 4. So you got x plus 3 times x plus 4 should not equal 0. We get x plus 3 should not equal 0, and x plus 4 should not equal 0. So we get x should not equal negative 3, or x should not equal negative 4. And the way you write that is the domain is all x such that x is not equal to 3, negative 3, or x is not equal to negative 4. Actually, technically, I think it should be and. Those two conditions should be both true. The first thing to realize is that all of these terms, in both the numerator and the denominator, actually, are all divisible by 3. So, the numerator is all divisible by 3, so I'm going to factor out of 3, and in the denominator I'll factor out of 12, and they'll cancel. So, we get 3x squared plus 2x minus 1 in the top, and then we get x squared minus 1 in the bottom. And you can see that this 3 and this here, they'll cancel when you leave a 4 in the denominator. So now we can factor. So noticing that I've got a equal to 3 and b equal to 2 and c equal to negative 1, and it's a quadratic trinomial, that means that you've got an exponent highest of 2 and there are 3 terms. What I'm going to do is I'm going to use the bottoms up method. So we multiply a times c to get what we put in the bottom of the factor x, that's negative 3. And then you put the b value in the top, that's 2. And you have to ask yourself, what are the factor pairs of negative 3? Here they are, and you can see that only one of them adds up to positive 2. And there it is. So you put negative 1 and 3 here, and then we can say that this is going to be x minus 1 and then x plus 3. And you take the a value and you put it as a fraction here and simplify that fraction. This simplifies to get 1, but this doesn't simplify, so let's move it here to get rid of the fraction. Bring the bottom up in the bottoms up method. It's very important to bring your bottom up. So then let's do the denominator. We got x squared minus 1. That's really going to be a squared minus b squared, where a is equal to x and b is equal to 1. So therefore, as I back substitute, it'll really just be a plus b, a minus b. That's not back substitution. This is back substitution. X plus 1 and then x minus 1. So we have a fraction whereby we get x plus 1 in the denominator and x minus 1. And then we have in the numerator x plus 1 and 3x minus 1 in the numerator. So finally, we can cancel. Because we did all that factoring, we can cancel. And the answer is 3x minus 1 over x minus 1. Yay. Here, let's factor out 4x squared from the numerator and 2x from the denominator. So we end up getting x plus 4 times 4x squared over x squared plus 3x minus 4. So then we have cancel out these two, cancel out this. It's just one left after this gets canceled. So let's factor the denominator in a factor x. We can see that a is equal to 1, b is equal to 3, and c is equal to negative 4. So it's just regular factor x where the b is 3, c is negative 4. And therefore we can say that the factor pairs of negative 4 are going to be 1 and negative 4, negative 1 and positive 4, 2 and negative 2. This is the one that works, negative 1, 4, so x minus 1, x plus 4, is going to be what the denominator is. So, rewriting this fraction, we're still left with a 2 and an x in the numerator, 2x, x plus 4, and in the denominator we've got two binomials, x minus 1 and x plus 4. Surprise, surprise, we do get to cancel, so we get 2x over x minus 1. Yikes, that's ugly. Moving right along, I'm going to start this problem out, but I want you to finish it. So what I'm going to do here, since this looks a little weird at the top, I'm going to factor out a negative 1. When we factor out a negative 1, what happens is this numerator becomes negative 1 times x minus 2. If you don't believe me, just redistribute the negative 1 to the x. It becomes negative, and the negative 2 becomes positive, and you get back to the original. Factoring the bottom, we get a factor x of, because a is equal to 1, b is equal to 1, and c is equal to negative 6, we get a positive 1 and negative 6. Well, the two numbers that multiply up to negative 6 and add up to positive 1 are negative 2 and 3. You can get that by listing out the factor pairs if you want. So I'm going to say this is going to be x minus 2 and x plus 3. Cha-ching, cha-ching, these cancel out. And I want you to tell me what the answer is. I want to give you just a quick word of caution. Make sure you only cancel factors separated by multiplication. Don't cancel the terms separated by addition. So what you shouldn't do is you should not say, look, there's a 2 and here's a 2 and cancel them out because there's addition here. You can't cancel when there's addition. You can, if you were to do that, you might mistakenly think that the answer is 6 over 1, which is 6, and it's not. It's not 6. If you add 6 plus 2, you really get 8, and 8 over 2 is equal to 4. So really the answer could be gotten only by factoring out something that's separated by multiplication. Which is why we have to factor so much. Here, we're going to keep on going. What is the greatest common factor in the numerator? That's got to be 2x. And then in the denominator, it's also 2x. So we get 3x plus 2 over x plus 2. That's times 2x, and that's times 2x, and they cancel out. So you're left with just 3x plus 2 over x plus 2. Here we get a factor x in the top. What adds up to 3 and multiplies up to 2? Well, that's 1 and 2. So therefore, on the bottom, it's going to be y plus 1 over, multiplied by y plus 2. Then this, y squared minus 1, that's going to be the difference of squares, so it's y plus 1 and y minus 1. Cancel, cancel. We get just this as the answer. Here we've got two rational expressions that are being multiplied by each other, and I just want to remind you what happens when you get fractions that multiply. Before you multiply, sometimes the easiest thing to do is to cancel. This becomes a 1, and this becomes a 7, and then this becomes a 5, and this becomes a 2, cancel out 2, and then you multiply across. 5 times 1 is 5, and then 7 times 2 is 14. And the same structure of all that canceling is going to happen again over here. Let's factor first, and then cancel where we can and multiply across. We get in the numerator, we'll get x minus y squared over x plus y times, I'm factoring out a 3, x plus y over, I see a difference of squares, so it'll be x plus y and x minus y. Okay. So, let's cancel before we multiply. Can cancel that. We're left with just 1. Let's cancel one of these. We're left with just 1. And so it looks like we've got 3x minus y over x plus y, because only the highlighted terms are left. So therefore, this is your answer. Let's do a similar thing here, but remember when you have division, you have to take the reciprocal. So let's just take the reciprocal. That means we're going to have multiplication of 2a squared b squared and a squared minus 2ab plus b squared. Just taking the reciprocal. Let's factor this numerator. We get a plus b and then a minus b. Factoring this denominator, you get, that's actually a formula, a minus b squared, and canceling an a and a b, you're left with just one a and one b. and then we can cancel one of these. So at the end of the day, we're left with 2ab a plus b over a minus b, and that is the answer. By the way, I just want to let you know that my favorite activity is rock climbing, and if you ever want to talk about your favorite activity, if it's rock climbing, great. If it's not, awesome, let me know what it is. Let's divide these fractions. So we get, in order to divide, we have to multiply by the reciprocal, so we just flip the second rational expression, and then we got to factor them. So here they are factored, and you can write them down, and then you notice that we have some things that we can cancel. And here they are, so I'm going to do a whole lot of canceling. This cancels this cancels this, and this cancels one of these. And what are we left with? The answer is just x minus y. Done. Looking at the next problem, we notice that we've got common denominators. So therefore we can just add the fractions. Like this. And now we have some like terms to combine. When you combine the like terms, you get 3x squared plus 4x plus 2 all over x minus 5. Now I'm pretty sure that you can't do a factor x bottoms up method here, but even if you could, one of the factors would not be x minus 5, so we've simplified as far as we can go. What happens when you've got fractions with unlike denominators? Well, you have to get the least common denominator. In this case, it's going to be 30. And you can multiply 6 by 5 to get up to 30, so therefore you have to multiply the numerator by 5 as well to get 25. Multiply 10 by 3, so therefore multiply 3 times 3 to get 9. Now you can add these fractions once the denominators are like. So we've got 34 over 30, and then you can even simplify a little bit to get 17 over 15. The same structure, the same strategy is going to apply here for number 12. Let's get common denominators. Well, x minus 5, we have to get 5 minus x, so we should multiply by negative 1. So now I've rewritten both fractions, but the second fraction I've multiplied all the terms both in the numerator and denominator, multiplied them all by negative 1. And when you do that, you get what you see. Now, adding them together, you get the common denominator in the bottom, and 2x squared plus 11, which cannot be factored any further. At least leave it like that. 13. We need common denominators. In order to get to common denominators, we need to factor. And so I factor the top. Here, it's a perfect square. And then I factored the greatest common factor out of the denominator here. And then here, we're going to use bottoms up method. A is equal to 2, B is equal to negative 3, and C equals to 1. So A times C is 2 times 1, which is 2, and then in the top we put the b value of negative 3. We have to list the factor pairs of 2. They're going to be 1 and 2. But 1 times 2 is not negative 3. 1 times 2 is positive 2. However, 1 plus 2 is not negative 3, so in order to fix that, we have to put them both as negatives. Now, negative 1 times negative 2 is positive 2, and negative 1 plus negative 2 is positive 3. So therefore, I can write my binomials like this. X minus 1, and then x minus 2, not forgetting my a value of 2, has to turn both of these into fractions. This cancels to get 1, and this bottom moves up here. 2x minus 1 and x minus 1. That's what this denominator is going to turn into. 2x minus 1, x minus 1. So now the question is, what's the least common denominator? I think the least common denominator is going to be 2x minus 1 times x minus 1 times, we already have an x minus 1, so I don't need to repeat it, times 2. I'll write that twice. That's because I can multiply each of these denominators by something to get the least common denominator. So, what do we have to multiply here? The question is, well, there's an extra 2, so I should multiply the top by the 2 as well. And what do I have to multiply here to get to the denominator? I need an additional 2x minus 1. So I'll multiply the top by 2x minus 1 also. You know what, for this next step I realized that maybe it's not as helpful to factor out this numerator up here, because I just have to combine what I see down below. So we get the common denominator of, I'll put the 2 out in front, 2x minus 1 times x minus 1. And then multiplying these two together, or foiling them, you get 2x squared plus 7x minus 4. Again, that's a result of foiling. The result of multiplying these out is 2x squared minus 8x plus 8. That's actually just double of this here. So now I have to combine terms. And when you do that, you get the same denominator, 2x minus 1, x minus 1. And now these add up to 4x squared. These add up to minus 1x, and these add up to positive 4. If you attempt to do bottoms-up method with this, you'll find out that nothing cancels, so I'll spare you the time on the video, and just say that that's the answer. Because if you try, you are unable to factor the numerator. And on top of that, I feel like this video has gone on long enough, so I would say same basic strategy here, except subtraction, like subtracting fractions. Here, you just have to go through the whole process once on the top, and then a whole process again on the bottom, and well, you got to combine things afterwards. So I'm just not going to do these, because the video is long enough. I want you to start your assignment. And the assignment is RF, I believe. Just do the first problem in your composition book. Write out the problem list, and then just start the first problem. And hopefully you'll have enough questions to bring to class. Take care, and I'll see you in class.